Hello guys, welcome back with me. Today we are going to learn about the simulation of fluid flow through venturi. As we can see in this picture in the screen, this is the picture of a example of a venturi with the exact measurements of this picture. And as you can see in the screen, it has three different parts. First is converging part, second is throat, and the third is diverging part. And as you can see in here that the converging part is shorter than the diverging part. Now what we're going to do that we will prove that the pressure 1, velocity 1 will be different with the pressure 2 and velocity 2 based on the Bernoulli equation. And we will plot some of the contours like pressure contours, velocity contours, and we will plot also the graph of the pressure and the velocity graph. And from that we can discover that there is a difference between the pressure 1, velocity 1 and the pressure 2 and velocity 2. Okay, let's get started, and don't forget to like this video, and probably you want to subscribe my channel. Thank you. Okay, let's get started with the Ansys workbench. Okay, after we open the Ansys workbench, as you can see in the screen, don't forget to save as the file first. In the destination folder, probably I want to create a new folder and rename it with the venturi 2, because I have already saved the other file with the same name of venturi. Okay, venturi 3D. In this tutorial we are gonna have a 3D model, so we will conduct a simulation in the 3D model. Alright, after saving the file, as you can see in the left screen, you will see the toolbox outline tree, and there are so many choices of so many options of simulation right there. And we will conduct the fluid flow using Fluent. Just click it simply and then drag it in the green box in the project schematic, and then release it to create a standalone system. Probably I want to rename it with the venturi 3D. Right. And on the right side of the screen there are properties of schematic of the geometry, and I'm not going to change many in these sections. I just want to ensure that our analysis type is on 3D. If in your workbench it is in default of 2D, you need to change it into 3D, because we're going to simulate the model in 3D model. Okay, let's get started with the geometry. Just simply right click on it and then click the new design model. Okay, actually it has two drawing modelers. The first is space claim and the second is design modeler. So I'm not familiar with the space claim, so I will use this design modeler. If you are familiar with the space claim, it doesn't matter at all, as long as you have the same measurements. I think there is not much problem if you use the space claim rather than using the design modeler. But for me, I am familiar much more using this design modeler, so I'm gonna use it. Okay, first, as you can see in the tree outline on the left side of the screen, in here there are three planes right here. I'm going to choose the XY plane, look at, and then first we change the units. Where it is in the default, it will be in meter. I'm going to change it in millimeter. and then switch the tab from modeling to sketching. Okay, first we just draw the line in the screen whatever we want. Just draw the venturi sketch as we want. So don't mind the measurement. We will change it later. Just draw whatever we want, and then change the dimensions into 30 millimeters. Okay, just a little bit zoom in. Right, we just draw whatever we want, as long as you sketch a typical venturi right here, just like this. Don't forget that the diverging part is a little bit longer than the converging part. This is very important because venturi is slit like this. Okay. Right. Now, second changing of the measurement is this horizontal line. We make sure that this is 200 millimeters. All right, and the third is this line. Gonna change it into 40. All right, this line is gonna be changed into 30. This line 40. Okay, and then this line is 60. And this line is 40, and also this line is 30. Okay, now we have done our sketching. The second things to do is creating a 3D models. In the XY plane, you just simply click the sketch that we have already done it, and then we click revolve in the pane up there in the above. Revolve in the details view. In the geometry, just click apply for already selected sketch, and in the axis we click this horizontal line in the center, and the angle is 360 degrees. Just let it be like this, and then click apply in the axis. All right, and don't forget to click generate. Sometimes we forgot to click it, just click it. All right, now we have done our 3D models right here. Okay, gonna save it. So in case in the future there will be some errors, we don't have to start over from the first time again. So we just opened our already saved file. All right, we return in our workbench. Now we go into the point number 3 in the mesh. Right click on it, click edit, and wait for the window to open. Okay, now we have our models have been open in the mesh window. Now which first thing is we're gonna do that we will create or generate the mesh for the model. Just simply click in the 3 outlines, click the mesh, and look at the details of mesh below there. We change the element size, which is in the default it is 0. Oh yeah, don't forget to make sure that our unit systems changing from metric, we change it into metric meters, we change it into metric millimeters. Okay, after we've done that, we change the element size into 3 millimeters. Hit enter in your keyboard, right click on the mesh again, and then click generate mesh. Okay. Alright, we have done our meshing is right here. Now we're gonna check our mesh quality, and how to do that in the details of mesh once again. Look at the display style, change from use geometry setting into skewness. Alright. Now what is exactly skewness? Skewness is the ratio or the difference between the shape of the shells and the equilateral shells. Right. In the legend, as you can see in the screen, it represents with the blue, green, red, yellow and red colors. So when the color of the cells closer to blue color, which means that the mesh is already good, in very good condition, the best cells will be represented by the blue color cell. And when it comes, or it is closer to the red zone or red color, which means that the cells are worse. So in our metals right here, most of this in the blue colors, which means that our mesh is okay. Second options that we can choose to examine our mesh quality is aspect ratio. So the aspect ratio is the difference or the ratio between the bigger cells with the smaller cells. And again, just like its skewness, that closest to the blue zone or blue colors indicates the good mesh or good cells, and closer to the red zone or red colors indicates the worst mesh or worse cells. Okay, after examining the mesh, I'm gonna change it in the geometry settings. And the next things to do that we should define the boundary conditions. And just simply activate the face selections, click this face, because I'm gonna use the converging parts surface area as inlet. Right click on it, create name selection, and we put or rename it with inlet. Click OK, and then the second one is the whole walls. Gonna select the whole walls, this, and then this. Okay, I have selected the entire walls, and then right click in one face, create name selection, and I want to rename it wall. Click OK, and the last boundary condition is outlet. This surface area of the diverging parts, I rename it with outlet. So these boundary conditions are very important to be defined, because in the Fluent they will translate these boundary conditions and automatically set it as, or read it as, inlet, walls and also outlet. If you falsely define the boundary condition, probably the Fluent will read it false also. So it is very important to define it first according to your drawing or your plan. Okay, after all, I finished to define the mesh and boundary conditions. Then the next things to do is update it. Wait until we got this information that the mesh translation to Fluent was successful, and then after that we minimize this window. Okay, and we go back to the workbench. We click on the point number 4, right click on it, click edit. Alright, in the Fluent launcher window, in the options we check the double precision. and then click start. Okay, after we open the Fluent window, the model, the 3D models will be like this on the screen. Now we go into the task page. We define our solver type is pressure based, velocity formula absolute, time steady, and we don't check the gravity, just like this. And then we go into the outline view, choose or expand the models, and then double click the viscose. Alright, for the turbulent model, we're gonna use the capsulant, and the model is realizable, and enhance wall treatment, and then click OK. Right, now the others I will not define it, and then double click in materials. As a default, the materials will be in air and the solid is aluminum. Now I'm gonna create it or change it. Open the Fluent database. In the Fluent database, I want my materials will be benzene vapor, exactly, C6H6. After we select it and click copy, close, change or create, close. Now we have already our benzene vapor available in the materials, right? And then double click the cell zone conditions. We change it from solid default, click edit. Alright, we rename zone as gas, and we choose the material name for benzene vapor, click apply, we close. Now we have already defined our cell zone conditions as gas or benzene vapor, and then we will define our boundary conditions. Double click on it, and the inlet, I'm going to change it into pressure inlet because I want to define the inlet as pressure based. Alright, we have already in the default in here that the units of the total pressure is in Pascal. Now I want to change it in the British unit as the PSI. Alright, just set units in the domain, and then in the quantities we select pressure. In the units we change it in the PSI, then click close. Now the total pressure units in the zone name in the boundary condition has already changed into PSI from Pascal. Now I'm gonna change it from 0 into 25 PSI, and then click apply. Right, close. And we edit in the outlet, just pressure outlet definition. I want to change it. Okay, just let it be in 0, click apply, close. Alright, next we go into solution, double click in methods. Alright, as a default in the task page the shim is coupled. I'm gonna change it to sepal. Gradient green goes as cell based, and make sure that all of the spatial discretization in second order to create much more accurate results. Okay, and then double click in controls, so just let it be like this, and then in the monitors expand it and double click residual. Alright, we change the absolute criteria from 0.001 into 1e minus 6, or 0.000006, 0 multiplied by 5, and then we copy it into all residuals. and then click OK. Now we go into the initialization, double click on the initialization. We choose the initialization methods of standard initialization, compute from inlet. Okay, and then just let all of them be set like that, and then click initialize. Okay, after it's done, we double click the run calculation in the calculation activities, and we set the number of iterations for 1000. Okay, actually for the convergence condition, it depends on you how many iterations it will be. Probably want it 1000, 2000, 3000. The most important that your computer requirements is sufficient to iterate for the simulations. All right, in here I just want to create 1000 for number of iterations. Okay, after we setting it, and then we click calculate to run the simulation. The Fluent will open the residual graphs or residual charts, so we can monitor the percentage of our iterations until it's done. Wait for a few seconds until it's open. Alright, after the scale residuals open, we can monitor our progress of iterations, and also in the below we can monitor also the percentage of the iterations until the number of iterations for 1000 is reached. Okay, we're gonna wait for a few seconds until the iterations are 100% or done. Now after the iteration has been completed, there will be an information of calculation complete, then click OK. Now what I'm gonna do next is plotting the graphics. First I want to plot the mesh, double click in mesh. Okay, we uncheck the faces and we will check the nodes and edges, and then click save or display. Alright, and I'm going to change the colors for the interior into light green, and also for the walls in light green, and then click close the save display. Alright, and I want to plot it in the results just like isometric view like this, and then we double click in the contours. Alright, I want to see the pressure contours of static pressure, and if in 3D like this we cannot see the inside of the venturi, what is going on there. So what we will do, just want to create a new plane. Alright, plane in the XY plane, and then click create in the position of 0 meter of C, create, close, and then we select the surface of plane 3 for control of pressure, and then we display it. Okay, we see in the Z view. Now as we can see in here that according to the legend that the colors of the contours represent the pressure. So closest to red represents the higher value of static pressure, and closest to blue represents the lowest value of the pressure. Now which we can see in here in the converging part, it is almost the entirely red, but when it goes into the truth, then suddenly change into blue, mostly blue or cyan or light blue. It indicates that the pressure value is decreasing, and then after it is coming out into the diverging part, it is changed in the green, light green or yellow colors. It turns yellow. So it indicates that the pressure is increasing again, but the values is less than in the converging part, which has the highest value of the pressure. Now that is the indication that the throat, the sudden changing of the surface area, is contributing for decreasing the pressure. Now the second counter I want to see is velocity. Just double click again in the counters and rename it into velocity counters. Alright. Change the counters of velocity magnitude, and again we select the plane tree and then display it. Okay. Alright, as we can see also that the colors indicates the value of the velocity. It reverses with the previous pressure, that in the throat it seems that the velocity value is the highest among all. So it indicates that the decrease of the pressure, it reverses with the velocity, thus the velocity is increasing. Instead of decreasing, it is increasing. So based on the Bernoulli equation, that the pressure is reversed with the velocity. So the increasing or the decreasing of the pressure, the increasing of the velocity. So it reverses between each other. Okay. Next things to do, I want to plot the vectors. Just double click in the vectors. Alright. Rename it in velocity vectors. Okay. And then we select the plane tree once again. The style of the vector, I'm going to plot it in field arrow with a scale of 0.5 and skip it into 3. Then click display. Okay, we want to change the skip into 0 so I don't skip it. Just let it be like this. Okay. Now this is the vectors of the velocity. As we can see in here, that the colors also indicates the value of the velocity. Okay, I'm gonna scale up the arrow again into 1 display. Okay, I think it is much more visible now. Alright, after the diverging part, we can see in here there is a vectors. If you want to zoom in this section, there is a vectors right here. So it's like a turbulence or flow back. Okay, and the colors is blue, indicates that the value of the velocity is decreasing right here. It is the contribution of the diverging parts. Okay, and we zoom out it again and then click close. Now we have discovered many things from the counters, vectors, etc. Now I want to plot some graph. Now how do we do that? I want to plot some graphs inside the venturi, exactly in the middle or the center of the venturi inside. Now we go into results and expand the surface, double click or right click and then select new and then create line or rake. Okay, we rename the surface name of pressure. I'm gonna plot the graph of pressure and velocity also. Pressure, and then select the time of line. And if we remember that in the sketch back there, the start of the sketch in the 0 position of the X, Y, and Z axis, there will be in the middle or in the center line of the inlet. So I want to draw the line exactly in the middle or in the center of the surface area of the inlet until the outlet in the diverging part surface area. So in the endpoints, the x0, y0, and z0 in this position, I want to plot it along, I want to plot a horizontal line along the x-axis, which means that I just want to change the directions of the x-axis right here. Before we do that, we change the units first in the length. Okay, length in here from meter to millimeters, and then click close. Now suddenly it's automatically changed. Now we just let the x0, y0, z0 in the 0 positions for all, which means that the endpoints of the start or the start point of this line will be in the middle or in the center of the converging part or inlet surface area. And then we change the endpoint. The end of the line will be at 200 millimeters, exactly at the end of the outlet, the middle or the center of the outlet surface area. And then click create. Alright, we have done our creating the line of pressure. And the second, I want to create also for velocity, because I want to plot also the graph for velocity. Okay, and the length or the positions also the same, the start from 0, 0, 0 positions and the end for 200 millimeters position, and then click create and click close. All right, we've done here creating the line, and so this line will contribute to plot the graph inside the venturi positions. Now the next things to do is we will go into plots, expand the plot, and then double click the XY plot. Alright, the first is pressure. We'll rename the XY plot name into pressure. Right, just let it be in the pressure, static pressure, and we change the x-axis function into curve length, so we will plot the graph in the very smooth curve. And in the surfaces, we click the pressure. It indicates the line of pressure that we have created before, and then click save or plot. Okay, I think we have done plotting. Oh sorry, there is an information that object with same name already exists, so we're gonna rename it on the pressure graph or pressure chart. Okay, so it seems like Fluent doesn't want to plot or doesn't want to plot it in the same name, so there will be no turbulence on it. So, and then after that we plot it. Okay, we have successfully plotted our pressures right here. As we can see that around 100 millimeters until 125 more a little bit, the pressure is suddenly decreasing from the start, which means that it is the middle of the length for the line, which represents the throat, the inside of the throat. So that means that in this position the value of the pressure is minus, so it is vacuum. So the pressure is decreasing when it through the throat, and then suddenly increasing again after it leaves it, going into the diverging part. Okay, now we're gonna see the velocity plot. Right click on the XY plot again, click new. We rename it into velocity graph or velocity chart. Okay, we change it from pressure into velocity magnitude, and also change the x-axis function to curve length. select the surfaces for velocity and then click plot. Okay, it reverses, as I explained before in the contours, that it reverses with the pressure, that the velocity through the throat is increasing. Instead of decreasing just like the pressure, it reverses. It is increasing and then suddenly decrease again when it leaves the throat going into the diverging part. Okay. Now we have already plotted many things. Then if we want to plot the reports, we go into the simulation reports, we expand it just down below there. At the end of the outline tree, double click in the report outline. Okay, actually we can plot many things, but I will just focus on everything that I have already plotted. I want to plot the headers, system information, geometry and mesh size, quality, okay, orthogonal quality, simulation setup, run information, name expressions, okay, and then plots, residual plots, okay, that's okay, mesh, contours, vectors. Okay, I will uncheck the path lines, FFT, scenes, animations, because I didn't create any in those options, and then I'm just want to keep the user data. Okay, now we will also set the contours position in the mesh first. The view is isometric, okay, I will just keep it, and we also can preview it. We also be able to preview it. And then in the contours, I want to change it into front, just preview, okay, because I just want to see in the surface area of the middle of the venturi exactly in the z-axis or xy plane. It is also the same in the pressure. I want to see it in the front, from the front. It's like this, okay, so we can see clearly what happened inside. And then for the XY plot, we can upload both of the graphs. All right, and then we click to generate report. Just wait for 5 seconds until the Fluent generates the report, and they will view it soon. Now, after Fluent has already done creating or writing the Fluent simulation report, we can see it in the window of Ansys Fluent simulation report, as in here that the descriptions of the analysis since from the system informations, geometry and mesh. We can view all of this, the number of cells, faces, nodes, mesh quality, also orthogonal quality, and also for simulation setup, physics models, properties, material properties, also benzene, vapor, solid, aluminum, cells and conditions, everything. We can view everything and we can write it in the simulation report. Also for the boundary conditions, the inlet conditions, outlet conditions, walls, reference values, sulfur settings, everything we can view in this report. And also for the plots, for the residuals, and then also the mesh counters, or counters for velocity counters, pressure vectors, and also for the XY plot of velocity graph and pressure graph. Now if we want to plot it as a PDF report, we just simply export it as PDF and then save it in the destination folder you want it. Okay, I'm gonna rename it in the venturi simulation report, and then click OK, and then wait for 5 seconds until the PDF is done created. Right, probably we just want to see it as a complete report in the PDF. I think the report that has been created by the Fluent is quite complete enough, so we can see everything since from the settings or the setup until the output of the simulation. Now I just want to check the results of right here. Okay, as we can see in here in the that report in PDF is so or very complete from the informations of the informations of the simulator, everything until the plot, residuals, and then the mesh, also the counters, everything is very complete. Okay, I think that's all for my video tutorials. Thank you very much for watching, and for the next time, inshallah, I will share to you again in so many educations video. So don't forget to come back to my channel, and don't forget to like also, and probably subscribe it. For the subscribers so far, I say thank you very much for you all. This is very useful for me to increase my capability of uploading much more or many more education materials in YouTube, and I hope this will be very useful for your future educations. And last things to do, I want to say thank you again for the subscribers, and goodbye. Wassalamualaikum warahmatullahi wabarakatuh.